All right, hello once again. This is Jeff Scott at Blackhawk Technical College. I've been going over the book chapters, chapters 1 through 12 of the Mirox MySQL second edition text, which will be used for the online version of 152-147, Relational Database Development for the spring 2016 semester at Blackhawk Technical College. Going through the first 9 chapters. Chapters 10, 11, and 12 basically try to introduce you to database design and implementation skills. Chapter 10, as you see right here, is how to design a database. Chapter 12 is how to create a database, how to create indexes, etc. And that's chapter 11, and chapter 12 is on views. So I'm going to jump back and forth between different things in here that I've created. But the author talks about this 6-step process for designing a data structure. So let's start there. All right. First, you have to identify the data elements. So in other words, you get something that looks like this. So let's assume that you get a job with a company, and every single thing that they do, and don't think this doesn't happen, every single thing that they do is done through paper copies like this. And they say, well, we want to modernize, we want to get our stuff automated, we want to put it in electronically, etc. Here's what we do. We want you to set us up a database system. All right? So you've got to go through here, and you've got to start to identify the different data elements. Remember that a relational database modeling system or database system should model a real-world environment, the one in which it's used. And typically what you're doing here is you're modeling objects, also known as entities, that exist in the real world. All right, and when you create your tables, each column or field of a table will store an attribute associated with the entity, and each row or record will be an instance of the entity. So to model the database, you can use a lot of different techniques. One of the ones that they talk about in this chapter here is an EER diagram, which is an enhanced entity relationship diagram. And I didn't even bring those up. But again, we can come in here because there are literally millions. And I can just go through these, and I'm sure that some of these are better than others. All right, I'll just grab the first one that happens to be here. And it's 40 pages, and it's on what? The Enhanced Entity Relationship Model. So it's going to go over a lot of this stuff. I'm going to save all this stuff out there, and I'm going to create a folder that's called Articles, and I'll put that folder also. So let me just save this. Save as. There's where I'm putting everything. So we'll just call this EER. All right, and if you look out here on the P drive, what you'll find is I'm starting to collect this stuff already. So I'm going to create a folder here that I'm going to call Articles. Articles. And I'm going to throw in there this stuff that I've been going over. All right, move it here. All right, so I will end up taking that and zipping it, and I'll put that out there on the system also. All right? All right. So again, the first step for designing a data structure is to identify the data elements required by the system. One way of doing this is to analyze the existing system. Okay, if there is one, you can also evaluate comparable systems, and you should be interviewing the people who are using the stuff. You should begin thinking about the entities that these elements are associated with, and that'll help you to identify the tables as you go along. All right, so you'll get something that looks like this. Then you have to start thinking about, okay, I've got this. How do I want to subdivide these data elements? So some of these elements that you see, things like vendor name, you'll want to break down into vendor first name and vendor last name. The address you might break down into a street address followed by city, state, zip, etc. So if a data element contains two or more components, you should consider subdividing them. All right, why? Because it's easier than to mine the data that you're looking for out of them. The extent to which you subdivide will depend on how you're going to use this. You can always concatenate things back together again like this if you need to. But now later, if I need to do a query that's just based on state or zip code, now it's much easier to do it this way than it is to do it this way. All right, so once you've done that, then you want to identify the tables that you have in there, and you also want to identify the possible fields based on what you have. Now the author goes through this and says that if you've got any data elements that you identified but you don't need, you can cross them out. If you've got data elements that are going to be added, all right, that maybe weren't there originally, you're going to put those in italics. If you've got data elements that are related to two or more different entities, you're going to put an asterisk after those. This is just the way that the author's doing it. You don't have to do it this way. All right? So then you're ready to start to identify your primary and your foreign keys. So you're ready to draw something that looks like this. And again, we've talked about this before, but the idea, two things of importance in here. Very hard to tell from the drawing, but vendor ID here, invoice ID here, and invoice ID and invoice sequence, they're bolded. That means those are the primary keys. Also, you see a dot here, and it looks like that crow's foot that we talked about before, but they colored it in, so it looks like a triangle. So not only are you identifying all the fields for each table, but you're identifying the primary keys, and you're identifying the one-to-many relationships between vendor and invoices, and between invoices and invoice line items. Each table should have a primary key that uniquely identifies each row. Even though it's not mandatory that you create primary keys, it's done all the time anyway. The values of those primary keys should really never change. They should be short and easy to enter correctly. And a lot of times you'll just create an unintelligible value that you'll call ID or vendor ID or invoice ID, etc. So if a suitable column doesn't exist, you create your own. If two columns have a one-to-many relationship, then you will take the key from the one side and add it as a field on the many side. So there's vendor ID over here, there's invoice ID over here. If there's a many-to-many relationship, we don't have one here, but here's one. So this is a contrived example. So this says I've got employee stuff here and I've got committee stuff here, and there really is nothing in common between them. So I create another table that consists, in this case, of just the primary key from my employees and the primary key from my committees table. And that's called a linking or join or junction table. And I do that so I'm able to actually link together the employees and the committees tables. So in other words, again, a relational database management system does not handle many-to-many relationships. So you break them up as we've done right here. With a one-to-one relationship, remember, it would be possible to take what we have right here and just change it so that it was just a single table. We've broken it down into two tables for whatever reason, and the reason really isn't that important right now, but we've done it anyway. All right? All right. Referential integrity. No orphan records. In English, what that says, let's look at examples here. If I've got a vendor here, and that vendor has outstanding invoices, I should not be able to remove a record from this table if that record is being referenced in this table, because that would mean my child table, invoices in this case, would be orphaned. It would not have a parent record. In much the same way, if I've got a record in the invoices table, and it's as long as it has one or more records in the invoice line items table, I should not be able to remove a record from here if it has related records here, because the same thing would exist. I would possibly have orphan records. So you don't want to be able to delete a row from a primary key table, insert a new row into a foreign key table, update a foreign key row, or update a primary key if it causes a relationship where I have orphaned records, or as they call them right here, orphaned rows. So if referential integrity is not enforced, good morning, and a row is deleted from the primary key table that has related rows in the foreign key table, it's said to be orphaned. All right? So that pushes us down here to normalization. And normalization typically means that what you're doing is you're taking tables and breaking them down into more tables. All right? Again, just so you see this, I've gone through here and found several. Here's a one that I just saw this. I thought it looked pretty good. The 3 normal forms, 20 pages. Normalization, 34 pages. Databases for beginners, 113 pages. Another normalization that's 34 pages. But I want to talk to you about normalization and try to put it into my terms. Combine what's both in the book with what I think you need to know and understand. All right? So, when you normalize a database, you're trying to make sure that you are reducing and ideally eliminating data redundancy. You can't totally eliminate data redundancy. All right, going back to the example that we looked at before, you'll notice there's redundant data because there's vendor ID here and here. There's invoice ID here and here. You need a certain amount of redundancy between tables so that you're able to relate the tables together. But what you don't want to do is add redundancy when it's not needed. So when you've got a database or a data structure that's not normalized, a table can contain information about 2 or more entities. It can also have what are called repeating columns that contain repeating values. If you've got a normalized database or data structure, each table contains information about a single entity, and each piece of information is stored in exactly one place. So to normalize a database, you run through what's called the normalization process. And when you run through the normalization process, there's actually 7 different normal forms that you can use. There's first normal form, second normal form, third normal form, voice cod normal form, fifth normal form, and there's domain key normal form, which is also called sixth normal form. That's either 6 or 7, but there's a lot of them. All right? So as you go through this stuff, let's go back and take a look. This is what I'm gonna try to do this. So I'm gonna come over here to Google, and I'm gonna type in here database normalization. You can see I've already got a bunch of it in here. All right, and the basics of normalization. This looks like it'd be pretty good. All right. So what is normalization? Here's the authors. It's the process of efficiently organizing data in a database. There's 2 goals of this process: eliminating redundant data and ensuring that data dependencies make sense. All right? So there's several different forms that normalization takes up. All right? And when you're in an upper level form, you've already reached the lower level. So in other words, if I'm in 5th normal form or 5NF, I'm already in 4NF, which means I'm already in 3NF, which means I'm already in 2NF, which means I'm already in 1NF. Now, most companies only go to 3rd normal form. So those are the only 3 I'm going to talk about. All right? So I'm going to start with the beginning, start at 1st normal form. So as it says, In first normal form, you've got very basic ground rules. You've reduced duplicative data. You've got separate tables for each group of related data, and each table has a primary key, which is one or more fields that uniquely identify each record. If you've done that, you're in first normal form. In second normal form, you're already in first normal form. You want to grab anything that's a subset of data and put them into separate tables. And it's like, wow, that totally makes sense, Jeff. All right, well, let's look at second normal form. So let's look at the article that they put there. We've removed subsets of data and placed them in separate tables. We've created relationships between these tables. So again, as you're working your way down, what you're doing is you're creating more tables, and each of these tables gets smaller because they have less and less fields in them. So let's look at the example that they give here. They say, let's say we've got a customer table that's got these elements. So we've got a customer number, a first name, a last name, an address, a city, a state, and a zip. And we might decide that, all right, so we make customer number our primary key, and based off of that, we can now figure out all of this stuff. That is true. But if I know somebody's zip code, I can figure out what their city and state is. So in other words, I don't need all of these fields in a customer table. I could stop here and just put in customer number, first name, last name, address, and I could put in zip as an example. And then I could grab the rest of this stuff and I could put it into a new table that had zip code as the primary key and city and state in it. Why am I doing that? Because then I'm eliminating a lot of redundancy. Because if I have thousands of records, the same state will be in there thousands of times, the same city thousands of times, etc. At least conceivably that can happen. So what I'm saying here is in second normal form, I want to make sure that each field depends only on the primary key and not on any non-key fields. So in this setup, I can figure out city and state based on the zip, which is not a primary key. So I pull those fields out and put them in their own table. Once I've done that, I am now in second normal form. And then finally, if I want to go into third normal form, they give an example here of being in third normal form, and they say, imagine that we have this. We've got an order number, a customer number, a unit price, a quantity, and a total. All right? An order number is our primary key. All right? So we're in 1NF. Okay? It says, are there subsets of data that apply to multiple rows? No. So we're in 2NF. But it says, what about the total? And this total field, this is technically this is a calculated field because it's unit price times quantity. So it really, I can figure out the total based off of one of the fields that's not the primary key. So it's, as it says, what we must do is we might do something like this and either remove that field totally, because in this case it's a calculated field, and if we do that, boom, we're in 3NF. All right, now were those great explanations? By all means, no. So what I think I'm going to do is I'm going to grab these articles that are right here, do a save as, and again throw them in here. There's 3NF, there's 2NF, here's 1NF, and I actually have saved this in the past because I've referenced this one before. So let's see. So there's just normalization basics, and over here someplace is first normal form. All right, so I've got those articles as well. And again, I'm just building a variety of stuff here. Second normal form, basics of normalization, first normal form, second normal form, etc. And I want to take all that stuff and put it inside of articles. All right. I'll leave that here. I'll throw this in there too, something I found online. So I'm building up a little library here of stuff. And when I get to chapter 12, what I'll do is I'll zip that and I'll add that right underneath where I have the articles on some of the articles that I put in there earlier. I don't remember what they were right now. Okay? All right, let's jump back into here. So in the book, they talk about 1NF, 2NF, and 3NF. I didn't want to just read out of the book to you. All right? You normalize because you can get data together faster. Okay? Stuff belongs with, you just put stuff that belongs with the stuff it belongs with, for lack of better words. So they go through the example in here. Sometimes you have to denormalize, which means that you're at a certain point, but you decide that for whatever reason, maybe you're in third normal form, you should only go into second normal form because it's taking too long to get the data, for example. All right, the sixth step in those steps was identifying the columns to be indexed. You index columns that frequently are used in searches or joins, that contain a large number of distinct values, or that are updated infrequently. So again, in the book here, they did have a very nice chart which went over here, the normal forms. There's the first, second, and third normal form. These are on page 295, and there's the other normal forms. All right, there's much more to it than I'm giving you. I have not figured out the homework yet for the class. I'm going to do that when I go home today. So will you have to do any normalization? We shall see. That's pretty much it, though, for this chapter.